This lecture, I will introduce density and specific gravity and the calculations related to the two terms. There are several objectives you need to achieve after this lecture. The first one, you should be able to define density, specific gravity, and specific volume. You should be able to determine density, specific gravity, and specific volume through appropriate calculations. You should be able to calculate specific gravity from data derived from the use of pycnometer and plummet balance. You should be able to apply specific gravity correctly in converting weight to volume and volume to weight. You should be able to understand specific volume. Let's look at the term density first. You might have learned this in your chemistry class before. Let's review it. Density is mass per unit volume of a substance at a certain temperature. The weight per unit volume. It is usually expressed as grams per cubic centimeter or grams per milliliter, same. The density of water is 1 gram per cubic centimeter or 1 gram per mil. Density, if we look at the equation of the density from the definition, density is the mass divided by the volume. Volume, if we change the format, and move the volume to the left side of the equation and density to the right side of the equation. Volume is mass per density. Mass, not per. Mass divided by density. Mass is density times volume. So 3 different formats include, density, mass, and volume. Let's look at this sample question. The pharmacist needs to measure 2.75 grams of methyl salicylate, a liquid, by cylinder graduate. The density for methyl salicylate is 1.18 grams per ml. What is the volume at 25 Celsius? How to do that? We have to use the equation on the previous slide. Let's look at here. Volume is the mass divided by the density. Mass divided by the density. The mass from this question is 2.75 gram. And density, also the value of density is also provided by this question. That is 1.18 gram per ml. So we just build up the equation and calculate. The volume at 25 Celsius is 2.33 ml. Another question. The density for chloroform is 1.48 gram per ml. We get 2 ml chloroform at 25 Celsius. What is the weight? The mass is the volume times density. From this question, the volume is 2 ml and the density is 1.48 gram per ml. We just multiply the two together and we get the weight is 2.96 grams. Another term, specific gravity. Specific gravity is a ratio of the weight of a substance to the weight of an equal volume of a standard substance. Water is used as the standard for the specific gravities of liquids and solids. Okay, water is the standard. And hydrogen is used as a standard gas. Let's look at the equation. Specific gravity is the weight of substance divided by the weight of equal volume of water. And here is a sample question. If 10 ml of sulfuric acid weighs 18 grams and 10 ml water under similar conditions weighs 10 grams, the specific gravity of the acid is. Density is 18 grams divided by 10 milliliters. That is 1.8 gram per ml. And the specific gravity is 18 grams divided by 10 grams, because the 10 ml water under similar condition weighs 10 grams. So the specific gravity of this acid is 1.8. Substances with a specific gravity smaller than 1 are lighter than water. Substances with a specific gravity smaller than 1 density is also smaller than 1 gram per ml. And opposite, substances with a specific gravity more than 1 are heavier than water. Substances with a specific gravity more than 1, the density is more than 1 gram per ml. The difference between density and specific gravity. Density of a substance is a concrete number, 1.8 gram per ml in the previous example, and it varies with the units of measure used. The density of water may be variously expressed as 1 gram per ml, 1000 gram per liter, or 62 pound per cubic feet. And the specific gravity of a substance is a ratio. SPGR is a ratio between like quantities. It's an abstract number. SPGR is 1.8. Has no dimension and is therefore a constant value for each substance. The specific gravity of water is always 1, no matter what temperature it is, because always the weight of the water, same volume water, divided by the weight of same volume water. So the specific gravity of water is always 1. And here I give you a chart, the specific gravity of various liquids. And if you look at this one, liquid petrolatum, okay, the SPGR is 0.87, and the water is 1, and the chloroform is 1.47. And if you look at the layers, the liquid petrolatum is the lightest, water is in the middle, and the chloroform is on the bottom. Let's look at the example questions. If 54.96 ml of an oil with 52.78 grams, what is the specific gravity of the oil? Let's look at the solution. The specific gravity of oil is here. We want to figure this out. And for the top, for the numerator, actually that is the weight of this oil. And let's look at the denominator. Denominator is the weight according to the definition of specific gravity. The denominator should be the weight of the same volume water. Same volume means the same volume as the oil. So we know the volume of the oil. We know the density of water. Okay, if there's no specific indication, we assume the density of water is 1 gram per ml, and we get the weight of the water with the same volume of this oil. And we calculate the ratio. So that means there's no unit for specific gravity, right? No unit here. And the ratio is 0.9603. Let's look at another example question. If 2 pints of a certain liquid weighs 601 grams, what is the specific gravity of that liquid? Actually, you have, because the unit for the volume is pint, so you have to do one more step of unit conversion. 1 pint is 473 ml. And the solution is here. The volume. the volume is 2 pints, right? So you have to do this one more step. And finally, get the volume is 946 milliliters. And the specific gravity of liquid is on the top. That is the weight of this certain liquid divided by the weight. You know, Y here is the milliliter is volume. Y here is the weight, grams. Because I skip one step. The density of water is always 1 gram per mil, right? So the weight of 2 pints of water is 946 grams. And you calculate the ratio. That is 0.635. Specific gravity does not have unit. So that is the answer. Something you must know. Specific gravities may be expressed decimally to as many places as the accuracy of their determination warrants. In pharmaceutical work, this expression may be to 3 or 4 decimal places. Because substances expand or contract at different rates when the temperature changes. So the accurate work, is needed to allow carefully for variations in the specific gravity of substances. In the United States pharmacopoeia, the standard temperature for specific gravities is 25 Celsius, except for that of alcohol, which is different. That is 15.56 Celsius by, the government regulation. So those two are something you must know. And let's go to another important equipment. This equipment is used to measure specific gravity. A pycnometer. A pycnometer is a special glass bottle used to determine specific gravity. Okay, if you look at the picture here, you will see, different shape, right? Of course, different volume. So, pycnometers. Generally available for lab use in volumes ranging from 1 ml to 50 ml. And for this one, for the left one, should be 1 ml. And if you can read the number here, actually the right one is 25 ml, but you can have even larger one, 50 ml. Pycnometer has fitted glass stopper. If you look at here, fitted glass stopper with a capillary opening. You may not be able to see the small hole here and the tube here, but that is a capillary opening to allow trapped air and excess fluid to escape, because we want accurate volume, right? And some pycnometers have thermometers affixed because the temperature is a factor in specific gravity determination. So for some very accurate cases, the thermometer is needed. And how to use a pycnometer? Okay? And first, you need to weigh the empty pycnometer. Only pycnometer, nothing inside, empty pycnometer. Then you weigh again when filled to capacity with water. Then you weigh the whole thing when filled to capacity with another liquid, not the water. The second step is water, and the third step is another liquid. And then you subtract the weight of the empty pycnometer from the two weights and calculate. Because you need to calculate the ratio between the two, between the weight of the unknown liquid and the weight of the water. Same volume, because you use the same pycnometer, right? And if you look at this slide, your slide show this slide, you will have a video for that. This video is important for you to watch because you will see this video. From this video, you will know how to use the picnometer. And let me show this video. Let's look at the example question. A 50 ml picnometer is found to weigh 120 grams when empty, 170 grams when filled with water, and 160 grams when filled with an unknown liquid. So please calculate the specific gravity of this unknown liquid. Actually, this question tells you how to use the picnometer, right? And let's look at the solution. Weight of water, that is 170, subtract 120. Why? Because this one is the weight when the picnometer is filled with water. And this one is the weight when this picnometer is filled with that unknown liquid. So the weight of water is 51 grams. And the weight of liquid, that is 160, subtract 120. Why? 160 is here, is the weight, total weight of the picnometer filled with an unknown liquid. And 120 as the first step. 120 grams is the weight of the empty picnometer. So the weight of the liquid is 40 grams. Then we need another step to do that. Weight of the substance divided by the weight of equal volume of water. Why equal volume here? Because you use the same picnometer, right? Let's calculate. 40 grams, that is the weight of the substance, divided by the weight of same volume of water. So the specific gravity of this unknown liquid is 0.78. Another method to measure specific gravity is called the plummet method. Actually, this method is based on the Archimedes principle. A body immersed in a liquid displaces an amount of the liquid equal to its own volume. The loss in weight for the body is equal to the weight of the displaced liquid. We can weigh a plummet when suspended in water and when suspended in liquid, the specific gravity of which is to be determined. The liquid is the sample liquid. And by subtracting these weights from the weight of the plummet in air, we get the weights of the equal volumes of the liquids needed. And plummet balance, actually here is the picture, plummet balance. And if you look at here, you can read from here, and you must 100% immerse the plummet to the liquid, okay, no matter it is water or unknown sample, okay, so you must 100% immerse it into that. Let's look at an example. A glass plummet weighs 12.64 grams in air, 8.57 grams when immersed in water, and 9.12 grams when immersed in an oil. Calculate the specific gravity of the oil. Weight of displaced water, that is 12.64 grams. Subtract 8.57 grams. And actually, that is 4.07 grams. That is the weight of the displaced water. Okay? And weight of the displaced liquid. So because we want to calculate the specific gravity of that oil, right? That displaced oil, right? So that is 12.64 grams. Subtract 9.12 grams. That is 3.52 grams. And remember, we use the same equipment, right? And the same plummet, right? So that means the volume of the plummet is the same. So the weight of displaced water and so the volume of the displaced water and the volume of the displaced oil, are same, right? They are same. So that's the reason why we can directly use this equation. That is 3.52 grams weight of the oil divided by the weight of equal volume of water, that is 4.07 grams. So the specific gravity of this oil is 0.865. Calculate the weight if we know the volume and the specific gravity. Specific gravity is the weight of other liquid and divided by the weight of equal volume of water. That is the definition, right? Definition. So weight of substances is the weight of equal volume of water times the specific gravity. Density of water is 1 gram per ml. We know that, right? And the grams, the weight of the substance in grams is the volume of the substances in milliliters times 1 gram per ml times the specific gravity. So this equation works, right? And volume is equal. So grams, that means the weight of the substance in grams is the volume of the substances in water in milliliters times the specific gravity of that substances. Actually, if we only look at this equation, the equation is not right, but the value is correct. The value is correct. The number is correct. Let's use this one, this example, this question as an example. What is the weight in grams of 3620 ml of alcohol with a specific gravity of 0.820? And if you remember, grams is the milliliter times the specific gravity. Actually, you will see. We only look at the number. Don't worry about the unit, okay? 3620 times 0.820. That is 2968. That is the weight of alcohol. And what is the weight in grams of 2 fluid ounces of a liquid having a specific gravity of 1.118? You need to do one more step of the conversion because you have to convert fluid ounce to ml, right? And here I give you the conversion. 1 fluid ounce is 29.57 mils. Let's look at the solution. 2 fluid ounces, that means we use 2 times 29.57 mil, right? And that is 59.14 mil. And grams is milliliters times specific gravity. We use that. Weight of liquid is 59.40 mil times 1.118. So that is 66.12 grams. That is the weight of this liquid. Now, if you know the weight and the specific gravity, now you need to calculate a volume. What should you do? Specific gravity is the weight of other liquid divided by the weight of equal volume of water. That is the definition. We have repeated this again and again, right? And from that equation we get weight of equal volume of water is the weight of other liquid divided by the specific gravity. And density, if no special indication, density of water is 1 gram per mil. So volume of water is 1 gram per mil equals to weight of other liquid in grams divided by the specific gravity. And because the volume is equal, so milliliters is the grams divided by the specific gravity. Only number works, not the units. Okay, let me emphasize again. Only number works, not the units. Let's look at the example question. What is the volume in milliliters of 492 grams of nitric acid with the specific gravity of 1.40? We know the number works, right? The milliliters is grams over specific gravity. And the volume of nitric acid is 492. That is the weight of this acid in grams divided by the specific gravity. And we get the volume of this acid is 351. And the unit is milliliters. And let's look at another example. Actually, this question gives you, pound as the unit. So you have to, same as before, you have to do one more step of the conversion. 1 pound is 454 grams. What is the volume in milliliters of 1 pound of methyl salicylate with a specific gravity of 1.185? Milliliters is the grams over specific gravity. Volume of methyl salicylate is 454 grams. That is 1 pound, right? I did not do the conversion because that is 1 pound. Divided by the specific gravity. So the volume must be, the unit must be, milliliters. So the volume of this methyl salicylate is 383.1. And here we have another example question. And this example actually asks you more. And actually asks you about the cost of 1,000 ml of glycerin. And the glycerin is the specific gravity for glycerin is 1.25, and so it is bought at $54.25 per pound, and you need to buy 1,000 ml, but you don't know the weight so far, right? Because when we talk about the price, that is per pound, right? You have to, figure out how many pounds for this 1,000 ml of glycerin. Then you can calculate. So first, you know the milliliters. You know the, you can do either way. You can do, you can calculate the pound for 1,000 ml, or you can directly, calculate the volume for 1 pound, right? And the volume for 1 pound, as we just, similar procedure as we did for the previous question. So that is 454 grams, right? Here, if you look at here, 454 grams divided by the 1.25. 5, and then you get, the volume, and then you calculate the cost in 1,000 mil, mil glycerin. So what's the cost? You directly do that. Then you get the cost is 149.37. One more step actually. You can also do another way. You can directly, you can do another way like this. Okay. You can calculate another way is you can calculate the volume of this 1,000 mil. Okay. The weight of the 1,000 mil, then you directly calculate from there too. Different approaches, but should have the same result. Some students may have confusion. So then when should I multiply? Then when should I, divide? Actually here I teach you a small trick. And this graph is called a specific gravity triangle. And if you look at it on the top, the G, that means in grams, the weight of the materials, weight of the substances, of the substance in grams. And the left bottom is the specific gravity. And the right bottom is the volume of this, of this substance in milliliters. So here, if you can look at the middle of the bottom, there is one, multiplication sign. Let's talk about how to use this graph. And, for this one, specific gravity is the grams over milliliters. Okay, only number works, not the units. Okay, let me emphasize again. So how could you memorize that? If you can memorize the graph, you will see gram is on the top, milliliter is on the bottom. So specific gravity is G over mil, right? And what is the specific gravity of alcohol that has a volume of 1,000 milliliters and weighs 8 to 10 grams? We can directly use this one. Grams, what's that? 8 to 10, right? And milliliters, 1,000, right? And so the specific gravity, don't worry about the units. Don't worry about the units. I know the grams and milliliters does not make sense, but we only look at the number if the unit we use is grams and milliliters. So the specific gravity is 0.81. That is the example question. Let's look at another situation. We know the specific gravity and the volume, but we don't know the weight. How should we do? What should we do? So if you look at the triangle, grams, that means the weight is on the top. Then bottom is the specific gravity and the milliliters. So grams, if you look at the equation, is the specific gravity times milliliters. Okay, let's look at the sample question. What is the weight in grams of 240 milliliters of light liquid petrolatum having a specific gravity of 0.87? Grams is specific gravity times milliliter. Okay, and that is 0.87 times 240 if we only look at the number. Okay, look at the number only. And the weight of this 240 mil light liquid petrolatum is 209 grams. And another situation, you know the weight, you know the specific gravity, but you want to figure out the volume. Okay, if you look at here, the volume is G. G is over grams, is always on the top, divided by the specific gravity. Okay? A prescription needs 45 gram glycerin. It is more convenient to measure the volume of glycerin. The specific gravity of glycerin is 1.25. How many milliliters of glycerin would be required? We use that. Mil is grams divided by the specific gravity. So 45, only the number, divided by the 1.25, we get the volume is 36 mil. Okay, all the three situations you can directly figure out from the specific gravity triangle. Okay, hopefully you can use that. Okay. For the weights of equal volumes of liquids, the more the specific gravity, the heavier the liquid. Give you one example. Specific gravity for liquid A is 0.86 and the specific gravity for liquid B is 1.25. If we measure 10 ml of each liquid, which one will be heavier? I mean the weight. We know specific gravity of B is more than specific gravity of A, right? And of course, according to the first statement we mentioned, on this slide, the first statement on this slide, we just read through. The weight of B should be more than the weight of A, right? If same volume, equal volume. Let's do the proof. Weight of liquid A is 10 times 0.86. That is 8.6 grams. And the weight of liquid B is 10 times 1.25. That is 12.5 grams. And from there we know, from the number, we compare the number. Same unit, we directly compare the number. Weight of liquid B is more than the weight of liquid A. So, for the weights of equal volumes of liquids, the more the specific gravity, the heavier the liquid. And for the volumes of equal weights of liquids, the more the specific gravity, the less the liquid volume. Opposite, right? And I'll give you one example. Same liquid A and liquid B. And if we measure 10 grams, this time is not 10 ml, 10 grams of each liquid, which one has less volume? And here, specific gravity of A is smaller than that of B, right? And so the volume of liquid A, we directly use 10 divided by 0.86. We get 11.6 ml. And the volume of liquid B is 10 divided by the 1.25, that is 8 ml. So from there we know, okay, for same weight of liquids, equal weights of liquids, the more the specific gravity, the less the liquid volume. So the volume of liquid A is more than the volume of liquid B, although the specific gravity of A is smaller than the specific gravity of B. And we talk so much about specific gravity. And what is the application of this value? Pharmaceutical applications. When a pharmacist wishes to convert the weight of a liquid or preparation to volume or vice versa, then the pharmacist can use specific gravity, to do that. And can calculate the equivalent strength of a preparation on the basis of either weight or volume. And if you work in the clean room in the hospital or compounding center, parenteral compounding center, in automated pharmaceutical equipment used by pharmacists, actually if you look at the parameter on the machine, specific gravity is the parameter used to prepare total parenteral nutrition added mixtures. You must input the value, the specific gravity of each component, each liquid you plan to mix. And next one is a case study. Okay, it is a case study. That's a very good case. And you have lactic acid, salicylic acid in the prescription, and flexible collodion, QS to 15 ml. And we don't look at the SIG because I want to focus on the calculation. Lactic acid is available as a liquid containing 85 grams of the acid in 100 grams of solution. The specific gravity is 1.21. Calculate the quantity of this solution in milliliters needed to fill the prescription. A, if we look at here, AA. A means of each, okay? That means you have, in this prescription, you have 1.5 grams of salicylic acid and also 1.5 grams of lactic acid. Okay, quantity of lactic acid to fill the prescription is 1.5 grams, although it is not written here, but A means that. And the source of, lactic acid, that is 85 gram acid in 100 gram solution. That means you have to calculate how many grams of solution you need, because the solution is not pure lactic acid. So you can build up the, the equation 1.5 grams per x grams over 85 grams over 100 grams. You need to figure out how many grams of solution you need to get 1.5 grams of lactic acid. And finally you figure out you need 1.8 gram solution for the lactic acid, for 1.5 gram lactic acid. And here, because this question did not ask you the weight of the solution, actually ask you about the quantity of this solution in milliliters. Okay, so you have to convert the weight to volume. And do you remember the triangle, the specific gravity triangle? So you can directly calculate the milliliter. You use 1.8 divided by the specific gravity of this solution. And you need 1.49 ml of this solution to fulfill this prescription. Let's look at another clinical case. A modified Ranger's irrigation has the following formula. Sodium chloride, 8.6 grams. Potassium chloride, 0.3 grams. Calcium chloride, 0.33 grams. PEG 3350, 60 grams. And the water for injection, you add the whole thing up to, add here means up to 1000 ml. Assuming that 980 ml water is used in preparing the irrigation. Calculate its specific gravity. Okay? And let's look at the solution. The definition of specific gravity, weight of liquid divided by the weight of the same volume water. So let's add all of this together. So the weight of the sodium chloride, the weight of potassium chloride, the weight of calcium chloride, the weight of PEG, and the weight of the water used. Okay? We use 980 ml water. 980 ml water is 980 grams. We add all of those together, divided by the same volume, the weight of same volume water. That is 1000 ml, right? 1000 ml means 1000 grams. So we calculate. And the specific gravity for this solution is 1.05. This slide introduces the clinical application of specific gravity. Specific gravity is an important factor in urine analysis. Okay, urine analysis. And in adult humans, normal specific gravity values for urine is from 1.001 to 1.030. Increases in specific gravity may be associated with dehydration, diarrhea, emesis, glycosuria, and so on. A specific gravity greater than 1.035 is consistent with frank dehydration. In neonates, normal urine specific gravity is 1.003. And, if the specific gravity of urine is too low, that means the patient may have renal failure and like diabetes insipidus and also other diseases or excessive fluid intake. Okay, so that is a clinical application of specific gravity in urine. And here, if you see this one, okay, you can see the
The new Pen urine specific gravity meters have a fully waterproof IP67 end fitting to allow the probe to be applied to the sample directly. The probe now in distilled water. The user now presses start to zeroize the instrument. The value expressed is for water being 1.000. The tip may now be dried. The probe now be put into the sample of urine to be made. Pressing start activates the read cycle and the value is shown within 2 seconds.
Another term, specific volume. Specific volume is also an abstract number, same as specific gravity. Actually, specific volume represents the ratio of the volume of two substances with the same weight at the same temperature. Same weight, but the volume is different. Two substances, right? But still a ratio. One substance is taken as a standard, usually water, same as specific gravity. And specific gravity is a comparison of weights of equal volumes. However, specific volume is a comparison of volumes of equal weights. Specific gravity and specific volume are reciprocals. When you multiply specific gravity and specific volume together, the product is 1. When we multiply them together, the two together, the result is 1. Example question. Calculate the specific volume of a syrup. 91.0 ml of this syrup weighs 107.16 grams. How could you do that? Actually, 107.16 gram of water measures 107.16 ml. You need to figure out the ml, right? The volume, because the ratio, the specific gravity, specific volume is the ratio between the two volumes. And you just do the calculation. 91.0 is the volume of the syrup, and 107.16 ml is the volume of the water with the same weight. And finally, you get the specific volume of this syrup is 0.849. Another sample question. What is the specific volume of phosphoric acid having a specific gravity of 1.71? You directly use the 1/1 divided by the specific gravity, right? Because we just introduced. When you multiply the specific gravity and the specific volume, you get 1. They are reciprocal to each other, right? They are reciprocal to each other. That means 1 divided by another 1. The number 1 divided by the one of the two, actually you get the other one. Okay, so you can directly use 1 divided by the specific gravity and you get 0.585. That is the value for the specific volume. Another sample question. If a liquid has a specific volume of 1.396, what is its specific gravity? Okay, same. You know the specific volume. You need to figure out the specific gravity. You use 1 divided by that. And you get the specific gravity of this liquid is 0.716. And let's summarize some important messages. Substances with a specific volume more than 1 are lighter than water. It's different from the specific gravity. Substances with a specific volume more than 1, the density is smaller than 1 gram per mil. Substances with a specific gravity smaller than one, opposite, right, are heavier than water. Substances with a specific volume smaller than 1, density is more than 1 gram per mil. It's just opposite to the specific gravity. It's different. This page shows you the homework. Actually, I have posted the scanned pages of the questions and posted it to our modules. And so please make sure you submit your homework on time, before the due, I mean. And if you don't do that, you lose points for the homework.